Hey everybody, Mrs. Bianchi. A parallelogram is shown below and they give you this. Now I made a copy of it here just because we're going to work with this in just a moment. What is the area in square centimeters of the parallelogram? Now this is the formula for finding the area of rectangles and parallelograms, and you might be wondering, well, why does it work for both? Well, I'm going to show you. Now, there's three numbers here, and many sixth graders are often confused about which numbers you need. So I do want to remind you that whenever you're finding the area of a parallelogram, you want to find the two numbers that are perpendicular to each other. And how do you know they're perpendicular? That forms a right angle. And I almost like to use this perpendicular symbol, which is right here, almost like it's an arrow pointing at the numbers that you need. So what's perpendicular to that? We have this number here of 2.8, and then we have this number here of 4.25 or 4 and 25 hundredths. Now let's explore why this formula works. If I take this triangle and I cut it off and I move it over here and I kind of examine what am I talking about here, I'm just going to trace over that with this tool here. Now, if we talk about what is this thing that I just created, so in fact, let me make it a different color so we can see it and pull it away. This is a rectangle, is it not? That's a rectangle. So if I take the one side, let's move this back so you can see it again. If we take this piece and we just switch it to the other side of the parallelogram, it forms a rectangle. So you would have to ask yourself, if I was going to find the area of this red rectangle, what would I need? I would need this number, 4 and 25 hundredths, and I would need the height of the thing, which is 2 and 8 tenths. So let's substitute those values in. 4 and 25 hundredths times the 2 and 8 tenths. Now, did you know that you can use estimation to clearly eliminate some of these choices that are not even going to be close? Why can you do that? Because we rounded this, if we round it down, it would be 4, but this number is actually higher than 4. And if we round this to 2, right, that's going to give us 8. Now, we know the number has to be significantly more than 8 because this number is almost 3. Now, if I rethink that as a 3, 4 times 3, that would kind of give us in the ballpark of 12, right? So we can look at choices that we can eliminate. Now, if you don't have a calculator and you're not allowed to use one and you have to show the work, then I would set it up, the algorithm, as 4 and 25 hundredths on top and 2 and 8 tenths on the bottom. And remember, you don't have to line up the decimals like you do with addition and subtraction when you're multiplying two decimals together. So you're going to go ahead and get started to do the 5 times 8, which is 40, and you'll do your thing and finish up. Now, when you're done and you have your row of work for the 8s, and then you have your row of work for the 2s, because you want to make sure you add a 0 before you start working with that 2, just remember you have to go over 1, 2, 3 to the left. So when you're done, you want to count over 1, 2, 3 to the left and put your decimal 3 to the left. So just be careful with that decimal. And let's review. You don't need this number. Why? Because it's not perpendicular to the base. This is the number that's perpendicular to the base. And I think this really demonstrates quite nicely why you would use those two numbers.